Hey Alec, what's up?
Hey, how's it going?
What do you have here?
Um, so I got a bunch of these nut drivers, different iterations. I'll quickly go through how I got to where I am now. So, trying to improve on this off-the-shelf nut driver. Um, the the two problems we're trying to fix is that the first one, the screws aren't they're kind of wobbly in here, and they're not coaxial with the axis of rotation, and so that means that when the robot's trying to insert one of these screws, the tip is like going in a circle like that. Um, so that was one problem. The other problem is that there's not a lot of lead in here, so if the robot doesn't hit the head in exactly the right place, it's not able to pick up the screw, and then we have to search for it, which takes a long time. So the first ones I made, I added a bunch of lead in, and I tried to 3D print it with a narrow shaft to go. This is here. If we just look in here, so this is the coupling on the robot that we're trying to mount it on. And so I was trying to 3D print it with a narrow shaft that would fit in there. And but the 3D this carbon fiber reinforced PLA is just not strong enough, so the shafts would just break off. So the first two, the shafts just broke off right away. And so then I changed to this design where instead of a shaft going into the coupling, it's a sleeve that goes around it. And so that's a lot stronger. But when we increase the diameter like this and it's around the outside, we started to have problems with axially aligning it. The alignment was hard to get right. But this one worked, and it showed, and I was able to test it with the robot, and the lead-in works really well, so that's good. Screw still wasn't sitting flat. So anyways, this is my final one that I'm about to start testing. So this has the sleeve around the outside, but then it also has a mandrel in the middle that goes inside the coupling. So it goes in the coupling and then around the outside. So this mandrel or pin in the middle makes sure that this nut driver is lined up perfectly with the coupling, and then the sleeve holds it on securely. And then I also added some really small features. You might not be able to see them on the camera, but now the head of the screw rests. There's three little bumps. There's three corners there, so it never actually touches the magnet. It's resting on three different spots. So this makes the screw so it's constrained in the right orientation. It's like if you have 3 points, it constrains a plane, and so it doesn't wobble. So I'm about to test that out.
All right, let's see. Oh, that caught it immediately.
So the axial alignment there is pretty good.
Yeah, that's pretty straight.
I don't know if we need that straightening step anymore. But yeah, this is definitely better than anything we've seen before in terms of how much the tip of the screw is moving. Yeah, I don't think this that step is making it any.
So it's checking, it's doing the whole seesaw thing now, huh?
Yeah, and it's measuring the height of this surface, and then it's getting the head of the screw to like an exact distance above the surface, and that allows us to control the compression on those springs exactly, and control the clamping force. So we have the clamping process is controlled very closely.
Oh, I think we hear it creak. That was cool. Thanks for sharing, Alec.
Yeah, my pleasure.